Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello dear students, I am Mr. Muhammad Sultan and this is my channel for physics. Today inshallah we will study Unit 1 in the first term for the second year secondary, which is waves. Unit 1 is waves. Unit 1 has two chapters. Chapter 1 is wave motion, and chapter 2 is light. Inshallah, today we'll study wave motion. Let's start. Wave motion. When I say wave, I think the first thing comes to your head is water waves. Yes, it's the most common thing when you think about waves. If you think like this, calm surface of water, and you throw a stone here. When you throw a stone here, this surface which was calm starts disturbance in this place. Does this disturbance stay in its place? Does this disturbance stay in its place? Of course not. It travels from this place to other place to another place to another place and so on. Good. So we have here disturbance that travels or propagate. Excellent. Before you throw the stone, this surface was calm and the particles, you can say that they were not moving. So you can say that the kinetic energy of them was minimum, approximately 0, for example. Here, they start to vibrate up and down, so they get energy. And this energy does not stay here. It is carried by this disturbance in this direction, in this direction, in this direction, in all directions. So the disturbance that propagates, it carries energy. Okay, this disturbance that propagates, it carries energy, and this is the wave. This is the wave. I have here again disturbance. This disturbance propagates, and when it propagates, it carries energy along. So here, what's meant by a wave? The wave is a disturbance that propagates and carries energy along. This is the wave. And we don't have only water waves. We have many types of waves, many examples of waves. We have water waves, we have sound waves, we have light waves, we have radio waves, microwaves, we have many waves. These waves can be classified into two types of waves. So all of these waves, we can classify them into two types of waves. So waves can be mechanical waves and can be electromagnetic waves. So they can be mechanical waves and they can be electromagnetic waves. Are they the same? Of course not. They are different. What is the difference between mechanical waves and electromagnetic waves? Before I tell you the differences between mechanical waves and electromagnetic waves, I want to give you examples. An example of mechanical waves is sound waves. And another example of electromagnetic waves is light waves. If you think about light waves as an example of electromagnetic waves and sound waves as an example of mechanical waves, you can get many differences without telling you. Like what? Can sound travel through space? Can sound travel through space? Okay, some of you said yes and some said no. If you think about the sun has tremendous explosions. It has very huge explosions. These explosions result in light and sound. So the explosions in the sun produce light and produce sound. What reaches us? Sound or light from the sun? Of course, yes. Light only reaches us from the sun. We don't hear any sound coming from the sun. Okay, why? Yes, because sound cannot travel through space, but light can travel through space. Sound to travel, it needs a medium. So here, it needs a medium. When I say a medium, you can think about something solid, something liquid, something like a gas. So when I say a medium, this means some of these here. So sound waves need a medium to travel through. Light waves, as an example of electromagnetic waves, when I say light, I mean all other electromagnetic waves. They don't need a medium. They don't need a medium. What does it mean? This means electromagnetic waves can propagate through medium and through space. Again, electromagnetic waves can propagate through space and through medium. Okay, they don't need a medium to travel through. They can travel either in medium or in space. Good, but here, sound waves as an example of mechanical waves needs a medium. This means what? This means it cannot travel through space. Good. If this is the only difference between electromagnetic waves and the mechanical waves? No. Mechanical waves are produced due to vibrations or vibrating object, vibrating source, which makes vibrations in the particles of the medium. What about electromagnetic waves? Electromagnetic waves. The electromagnetic waves are produced due to the vibration of electric field and magnetic field. So we have here electric field and the magnetic field which are vibrating, but here the vibrating is the source and the particles of the medium. Good. So we have here two things: vibration of the particles, vibration of two fields, electric field and magnetic field. What else do we have? You know that thunder and lightning take place in the same time. Thunder and lightning take place in the same time. Which one of them reaches us first? The lightning, the light of lightning, or the sound of thunder? Do we see the lightning firstly, or we hear the thunder firstly? Of course, yes. We see the light of lightning before we hear the sound of thunder. You know why? Which comes first? Light, so it is faster. So electromagnetic waves are much faster than the mechanical waves. Electromagnetic waves are much faster than mechanical waves. Okay, and we have another difference, which is mechanical waves can be transverse waves and can be longitudinal waves or longitudinal waves, but electromagnetic waves are only transverse. We don't have, in electromagnetic waves, we don't have longitudinal or longitudinal waves, but here we have two types. Mechanical waves can be transverse waves and can be longitudinal waves. Do we have another example of this? We have many examples of electromagnetic waves. We have radio waves, we have gamma rays, we have X-rays, we have ultraviolet, we have infrared, microwaves, many types of waves here. All of them have the same properties of light. Mechanical waves, yes, we have sound waves, we have water waves, we have waves in a string, and if we have a string like this, these waves, due to vibrations of the material or the medium of the spring. So the spring itself is a medium. Okay. After finishing comparing the mechanical waves with the electromagnetic waves, now we will study the requirements of mechanical waves. So what do we need to produce a mechanical wave? We need to produce a mechanical wave. Mechanical wave is produced due to vibrations. So we must have a source that is vibrating. So we must have a vibrating source. Good. Vibrating source like what? Like tuning fork. Tuning fork. Like vibrating stretched string. You know, like that one in the guitar. It's a string that is vibrating. Okay. Or we can have a pendulum. You know the pendulum? Of course, yes. The pendulum. So this can be considered a vibrating source. This source produces vibrations to make wave. What is wave? A disturbance, yes. So this vibrating source produces vibrations to make a disturbance, which is a wave. This disturbance needs to be carried. Oh, what are these mechanical waves? Mechanical waves only propagate through a medium. So I need here a medium to carry the vibration or the disturbance. So I have here, these are the three requirements needed to produce a mechanical wave. We need a source. Yes, we need a source. This source makes vibrations. These vibrations work as disturbance from the source to the medium. Okay, and to carry or to enable the mechanical wave to travel, we must have a medium, because mechanical waves don't propagate into space. They always need a medium. Good. We have here, as we said, that we have vibrations and vibrating source and these things. To make it easier or to make it simpler to study vibrations, we have to know some concepts or some parameters related to the vibrations. Look here. For example, I will draw here an example of a vibrating source. For example, here I have the simple pendulum. You know that the simple pendulum is like this. A pop here is attached to a string. Good. This is the pop. طيب, this pendulum does not move. It is at rest. So this position is called the rest position. Good. Or you can call it the equilibrium position or equilibrium origin. So you can call it equilibrium position, rest position, equilibrium origin, the same thing. Good. I will take it here, some distance, and release it. Take here, for example, and I will release it, so it will move from this point again here, then to the opposite side, and this motion is repeated. That's why it is called periodic motion. Why? Because it is repeated regularly. Good. Look here. This pendulum, it moves from here to here, for example. So I have, for example, at a certain time, it moves from this position to this position. And so this position is away at a distance from this point, from the rest position. Okay, or it can be here. Yes, it can be at a certain distance after a while. After a while, it can be here. To be clearer, after a while, it can be here, or here, or here. It can be here, here, here. It can be at a distance from here, at a distance, and a distance. Okay, what are these distances called? These distances are called displacement. Yes, it was here in this place, but I displaced it, or it was displaced from this position to be here. So any distance away from the rest position is called displacement. Again, any distance from the rest position is called displacement. If it is here, 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 any distance from this is called displacement. So the displacement is the distance covered by this pendulum at any time, or the vibrating source or the vibrating object at any time. It is the distance away from the rest position at any time. Good. So the distance can be here. Good. What is this? This is the maximum distance. Excellent. Or the maximum displacement. Good. Is this the same as this? Yes, it's displacement and displacement. But we must distinguish this from the other. The maximum displacement, we call it amplitude. So the amplitude is a displacement, but not any displacement. The amplitude is the maximum displacement. It had a symbol of A, and of course it is a displacement, so it is measured in meters. Again, what is the amplitude? The maximum displacement away from the rest position. That's the maximum displacement made by the vibrating object away from the rest position or the equilibrium position. That's all? Yes, of course. طيب, Can you give us another definition? Okay. Look here. When I move, or when this pendulum moves from its rest position toward this point, for example, as it moves away from the rest position, its velocity or its speed decreases, 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 decreases till it reaches here. It stops here. When it reaches here, it stops. When it stops, this means what? This means the speed here is 0. طيب, it moves back, so it speeds up, speeds up, speeds up, till it reaches here, so the speed here is maximum. Why maximum? Because after it passes this point, it starts to slow down again, slow down, till it reaches this point to be here again, v equals 0. So teacher, you mean that we can define displacement as, we can define amplitude as the displacement between 2 points. At one point the speed is maximum and the other point the speed is 0? Yes. Yes, you can say this. You can say that the amplitude is the displacement between 2 points. At one point of them, the speed is maximum, and at the other point, the speed is 0. So I can say here the maximum displacement or you can say that it is the displacement between 2 points. At one point the speed is maximum, and at another point, or at the other point, the speed is 0. That's all? Of course, yes. طيب, do we have another parameter here? These are the parameters related to the vibrations, or you can call it concepts, anything. The third thing here is, want to change. The third thing here is complete oscillation. What is meant by complete oscillation? What is this? Oscillation, vibration. So it's motion. Yes. Which motion? Look here and you will know. I have here this point, I can call it, for example, A, and this point is B, and this point is C, for example. طيب, when this bob, or when the pendulum, when the vibrating object moves from A to B, in this direction, to the left, please pay attention to this. When it reaches B, it moves back to A. After reaching A, it moves back. It moves. It's continuous moving to C. After that, it moves to A. So it will pass A to the left. Good. This is the complete oscillation. Teacher, we didn't understand anything. I know. Don't worry. Look here. Complete oscillation, we said that it's a motion. Oscillation means motion, but not any motion. It is the motion of the vibrating object, the motion of the vibrating object in the interval. Yani it takes time. What is this time? It is the time between, or the interval between, passing a certain point twice or two successive times in the same direction. So here it passes by point A once to the left. Good. After that it passes by A but to the right, so I don't count it. After that it comes from C to A, so it passes A to the left. So between starting motion from A to B, and again from C to A here again, to reach A here again to the left, this motion is called, or the motion between these 2 points is called the complete oscillation. So the complete oscillation is the motion of the vibrating object in the interval, in the period of time, okay, between passing a certain point, two successive times in the same direction. Okay, طيب. I will erase this. If I start from A and move towards C first, start this motion. طيب, it will move back from C to A. Good. And from A to B. Good. And from B to A again to the right. So here, this vibrating object passes by A twice to the right, two successive times to the right. Okay, so I have here how many amplitudes here in the complete oscillation. Look here and you can get it. This is one amplitude between this point and the maximum displacement. It is the amplitude. Again, it moves back the same amplitude. It moves here, amplitude, and it moves here, amplitude. So I have here 4 amplitudes. So the complete oscillation includes 4 amplitudes. Good. That's all. I will not repeat it. Number 4, we have another parameter, which is the periodic time. Periodic what? Time. So when I want to define it, or when I want to explain it to anyone, okay, firstly, its symbol is T, capital T, capital T. Look here, it is very easy to know that the periodic time is the time. The periodic time is the time taken to make a complete oscillation. That's all. Again, the periodic time is the time. Which time? The time taken to make a complete oscillation. So the time needed to make a complete oscillation is the periodic time. To make a complete oscillation, what do we need for time? We need the periodic time. So the periodic time is what? The time to make a complete oscillation. That's all. We measure periodic time in time. So it is measured in seconds. What about number 5 of the 5th parameter? The 5th parameter is frequency. What is the symbol of frequency? The symbol of frequency is, look at it. No, not V. It is called nu. Nu. Okay, it's a Greek letter. Look at this. Nu. Nu. You call it nu. Okay, so frequency, new. What's the frequency? Oh, the frequency. If I ask you, what is your frequency of going to school? You can say that I go to school 5 times a week. So you count something and per time. The same thing here. So the frequency is the number of complete oscillations made in 1 second. Again, the frequency is the number of complete oscillations made in 1 second. So if I want to get it by a rule, it is the number of oscillations divided by time. The time must be in seconds. So the frequency equals the number of complete oscillations made in 1 second. So when I want to calculate it, I divide the number of complete oscillations by time in seconds. I get it, for example, it equals 5 watts. And when I say the frequency equals 5, yes, 5 watt, we are in physics. We must have units. The unit of frequency is hertz. Hertz. Or you can say it is second power negative 1. Yes. The unit of frequency is hertz, or you can say that it is second power negative 1. Can I say, teacher, can I say oscillation per second? Yes. Of course, yes. You can say that. The frequency equals 5 oscillations per second. Can I say 5 vibrations per second? Of course, yes. Can I say 5 waves per second? Yes. But this is the most common unit, hertz. The most common unit is hertz. So when I say the frequency equals 5, the first thing comes as a unit is hertz. Okay, these are the 5 parameters related to the vibrations. So what is the relation between the frequency and periodic time? Do we have a relation between them? Yes, teacher, you said here second, and you said here second power negative 1. So we have a relation here. What is the relation here? Look at it and you can get. The frequency equals the inverse of the periodic time. Or you can say that the periodic time equals the inverse of frequency. Okay, cross multiplication. So the frequency multiplied by the periodic time equals 1. So we have here these 3 equations, or these 3 relations are very important. If I know the periodic time, I can get the frequency. If I know the frequency, I can get the periodic time. And these things can come as multiple choice, as you know, in the test. This is the end of our lesson today. Thank you very much. See you next time, inshallah. Good luck to you all. Assalamu alaikum wa rahmatullahi wa barakatuh.